for working with you, Alice, and setting
Yes.
us up, and Sandy, of course,
You
who
bet.
informs everybody about our meetings. And I'm Annette Herlihy, president, and I would like to welcome our members, our guests, and our new members. And it's like I said, we're looking forward to your talk. And if you already explained, you're going to start your presentation and then halfway ask questions. Anybody can ask.
Yep.
And oh, here it is now. Raymond is setting us up.
Yep.
We're getting there. Yes. Okay, I guess we can.
All right. I hope I've got the right version.
Yeah, let's see. Okay, there's a. It looks like it's coming any moment.
Hey, maybe that's it. There we are. How are you doing now? Can you see it?
Well, there's not much. There's only four windows, I guess.
We only see your desktop at this point.
Yeah.
Okay. New share. I'll try new share. Try this one. How are you doing there? Is that it?
No, we're still not seeing. We're seeing your desktop.
Well, I don't know. What am I doing wrong then?
Haven't seen your mouse move around. It's been sitting in the upper right-hand corner.
Okay. Well, I don't have a mouse. I have a pad, but that's okay.
And this is a PC. Is this your PC or?
No, this is my this is my Mac.
Okay, we're seeing.
It says you're screen sharing.
Yeah.
Yeah. It says it's screen sharing.
Are we? Is your computer called LM?
I don't know what you're saying. I'm going out and trying again. Okay. So do you want to take over then and shall you advance the slides so we don't waste time? I'm trying to share the screen, so I don't know what's going on.
Well, can you go ahead, Alice?
Yeah, I just need to get a picture up there so you can see it.
Yeah. Oh, here it is.
All right. Woo!
Oh, this is cute.
Yep. I figured this would be the right thing to say.
Yeah. This is funny.
Yeah. That's from my friend Heather. I'll mention her later.
Oh,
But I want
okay.
to call it destabilization, because what we're realizing is there's more extremes more often and we don't know when they're coming.
Yes, exactly.
Yeah. So first of all, it's delightful that you've invited me, and I thank you for this opportunity. And if I go too fast, slow me down, stop me, ask questions, do what you like. I'm here for your benefit, right? So
Right.
here we go.
Okay, great.
All right. So this is who we are. Started in 1987 and dealing with trees from about 97 on in all forms of measurement everywhere in different programs. Because I'm a retired science teacher, right? So tonight, here we are. These are the topics we'll be running through. And we'll get to the end, which is your candy. And we'll take you to 2050 for gardening. This is a summary of our programs. They all have little letters behind them, which we use as short forms all the time. But we're always measuring, always working with community, whether they're planting or measuring or in a forest, whatever, on a long time along a river. It's all the same idea of the very basic protocols that everybody can learn. And the very simple equipment, you can even make your own, as long as it's accurate. We've been working on repairing rangers for a while with the province and putting in planting for change type plots for type of thing with 1,000 trees planted and 100 monitored and measured and tagged permanently for ongoing research as to what grows where best along the water course. With each of these conservation authorities, they chose the trees and we did help them with the measurement. And then we have over 60 schools around the GTA that all have the same suite of trees from the same nursery. And that sort of eliminates that variable. And so we have trees from representing the north, like the white spruce, and the hop tree representing the south. And in the middle, we have temperate trees, bur oak, sugar maple, and basswood. So that's every school has the same trees planted by the kids and measured by the kids and mulched every year, maybe twice a year. So here's a break for you as participants. You know what forsythia looks like. Have you looked inside the blossom? Do you know the parts of the blossom? Number one, somebody yell out. Petal?
Petal.
2. Anther and filament. Stamen. 3. Pistil. Or the filament, maybe it's the filament of the stamen. And then we have a little fat ovary, number 4, which you can see blowing up on the right-hand side in my finger with the little sepals and then the fat little ovary with the style and the stigma. I just want you to know that those parts, if you don't already, but you probably do, but they're in every flowering plant, whether it's wind pollinated or insect pollinated. Generally speaking, unless the sexes are separate, which happens in these cases in some flowers. Anyway, I just wanted to let you know that this is all by me trying to get ready for your presentation last March. Okay, so now we go up in the air. Here we are standing on the earth, looking up about 11 kilometers and about 3 millimeters of ozone, which is like our ultraviolet umbrella. And so those are the layers that you'll see there, but you're not aware of all that pressure on your head when you're out there walking. But you are aware of the ultraviolet coming to burn your skin. And it doesn't matter what color your skin, you still need to put on sunblock because you have to look at that SPF factor and know that it's only good for about half an hour or so. Yeah. Okay. So the jets go underneath that usually. And so now, knowing that that's the case, weather is what you're getting on the ground, like a snapshot, short term, today and tomorrow and maybe next week. So very unpredictable because of the local effects like lakes and mountains and Niagara escarpment and slope and altitude where you live. But climate is the long-term look from 800,000 years when we started doing ice cores to get that data. To get the gases out of the ice cores. We now know what climate is and we can predict it, generally speaking. However, now it's destabilized and uncertain. So the forces that make up our climate that we have are the 4. And you know that the sun reaches the earth and we can change that with volcanic ash like in St. Vincent right now. And the tilt of the earth, of course, as you've all done that in geography class. But what you might not have realized much is that the earth reflects light from the snow, from the ice, from the water, but it also absorbs water in the water. Darker water, more heat goes in there. Darker clothes, you have more hotter in the summer. And also when you take the trees away and you have just the soil, it's also not reflecting as much. Asphalt will absorb the heat. You know that the tar on your driveway, for example, gets soft. And all these things, we have a reflection index, which is can be measured. So, and we can also measure the concentrations of the greenhouse gases like CO2 and methane in the atmosphere, and those are changing as well. So the two things in red are what we have changed. And the volcanoes have changed #1 recently. Okay. So to understand what's going on the planet, and we're back up as astronauts looking at what's going on Earth, these are the red arrows are the winds coming off the Pacific, and the blue ones coming down from the Arctic as the Earth turns. And those are, so we call those westerlies because they're coming from the west. And then down below the Capricorn and Cancer, and as you go further south, the winds change and make a little bit of a switch back to going east. And we know that the Caribbean east comes from as far away as Egypt, picking up sand from Egypt and poisoning the coral around the Caribbean. So it's quite interesting. At that level, the winds pick it up and carry it across the ocean. And as they get hotter and hit the Caribbean basin, they get a lot of heat, and that's where we get the hurricanes coming. But the beige ones are where you have the deserts and the dry areas to grow crops or do something different, and we know where those are. So that's the big picture, right? It's the stratospheric picture. But and we're on the ground, and you'll see that the warm air is rising in those cells, going up and cooling and higher up, and then coming back down. So those cells we're living under one of those cells on our latitude. So here's what you probably look in the newspaper when you look at the Toronto Star, for example. On the back, they have a climate picture diagram of where the jet stream is and what's going on with their weather. Not the climate, but the weather. And here's why meteorologists like to work in Ontario, because there's cool, dry air coming from the Arctic, and there's hot, moist air coming from the Caribbean, and they meet in Ontario. So we have the most unpredictable weather of all here. It's more exciting for meteorologists. So here's what you look at. Oops, sorry. When you look at the newspaper, you may see something like this. And now you understand the polar thrust, as they say. The polar air is coming down and pushing everything down, the jet stream's going down. So we may have a loop-to-loop things coming off the Pacific or pushing back from the east, but it lets you know in the big picture way what the weather's going to be doing with the highs and lows. At the fronts, you're going to have storms. And the fronts where the highs and lows meet. Okay. Do you know what this is? Anybody know? No?
Seal.
Aha, a native too. Okay, good. So now we go back to the ice cores from 800,000 years, because they have a special way of doing this. It's quite amazing what they do to extract the gases from the ice. But it started out in 800 years ago as 190 parts per million, ppm. And then it went up and down, depending on the cycle, of course, the seasons and stuff. And then we get to about early 1900s, late 18 somethings, and we go sky high. Guess what happened in there? What turned that arrow to go up? That graph. Anybody guess? Late 1800s, early 1900s?
Industrial Revolution.
Earthquake?
Yes, no, the Industrial Revolution. You're absolutely right. We're burning more fossil fuels all the time. And so up we go, and we're still going up. You can look at this up on the website on the internet. And I did it in April, and I saw it was up to 416 parts per million. And the scientists were trying to pull us back at 400, but we passed that already. So that's it. Carbon dioxide. And that's what Al Gore started his master's on in Hawaii years ago when they were first measuring that. He was graduated in science. Okay, so here we are. This is not a virus. This is our weather. This is our weather. So global temperature change in degrees Fahrenheit. And what we're looking at, as you see, the black line is real observations from 1900. And then what we've been recording, we never separated nature out till recently. And now you can see that nature's doing a little bit of cooling, but the humans are pumping it up. So up to 2000, we're beyond that now. So just continue your trajectory with a dotted line, you'll see we're going up. Okay, well, you all know those curves these days with COVID. Does anybody know what this one is?
Ooh,
Geodoxa. Geodoxa.
Scylla.
Okay, Celia?
Celia or Geodoxa?
I don't know. I don't know the difference.
They're Scylla.
Okay,
Are they?
okay,
I don't think so.
good. Beautiful little guys. Okay, tying it all together, this is what it looks like for us. We're living on the earth and we're letting nitrogen oxides out of our exhaust pipes, and it's cooking in the smog with UV, making smog with UV and those gases. And so that's not very good for your respiratory system. But we're also producing more CO2 to go up and build under that layer of ozone, and more methane, which is about 80 times more dangerous than CO2. So it doesn't take much methane to cause a lot of trouble. And that's what we're worried about as our boreal forests start to rot. Or we have more livestock. So gases are produced, methane, we're going to have more damage. So, and also the ultraviolet, if you look over on the left-hand side there, we're going to have plastics degenerating, we know that. Our white sheets on the line will smell good as we bring them in because we irradiate them with ultraviolet and kill the germs. But we're also getting more cataracts and skin cancers, melanomas and things like that. And I might say that if you're looking at skin, most of the damage is done before you're 18. And a lot of kids did. One of my friends was a lifeguard and played outside all the time. And so she's dealing with melanomas, little ones, and so on, and having to have them checked all the time. But we have to be aware that we have to wear sunblock, no matter what. Okay. So that's what's going on. And up in the ozone layer, what's scary too, is that the ozone is a 3-molecule thing of oxygen, triangle up there. It's very unstable. So it switches back between 2 and 3 and 3 and 2 and so on, depending on conditions. But what we've done is screw it up with CFCs, the fluorides, and that's why the Montreal Protocol banned making Freon for your fridge, because it was upsetting that. And we're still doing that. Those are called the volatile organics and things like that. So we're trying to cut those down. And that was a global meeting in Montreal. And before that, Toronto had a very first climate change thing. And before that, even, it was wonderful. We were leading the way at that time. So I'm stopping with the technical stuff and the academic approach. If you'd like to ask questions, anybody, feel free. Put up your hand, whatever. Ray will let you in. If not, yes. Okay, got a question?
What was CH4?
Methane.
Okay.
Methane. Better known as a fart. Remember, the kids in college used to light their farts not with a lighter or a match. That was methane. To be crude. Any other questions? Please feel free. Well, it's all available to you. I'm not going to rush away, and we might be able to do more with it, but let's move on then. If I'm going too fast, stop me. So here we are. We've got choices like Goldilocks. I want you to see the X. Do you find the X? That marks Toronto's spot. Now I want you to look up at the years. That's 51 to 80. And look over and you'll find yourself on the scale of blue, where you are, what your annual temperature would be in that year up to 1980. Can you find yourself there in Scarborough? Whatever color that you are there? Okay, now watch the years go by. There we are. We've gone up. Okay. Now again, Watch the ears. Here we are. Look again. And you'll notice over in the left-hand corner, that sort of funny little spot, sort of blob. That's because the Dufferin Arch, the Algonquin Arch up in Dufferin County is higher. It's a geological feature which is higher as it goes from Ottawa over to Windsor. And that's the high point in Dufferin County area. In case you're wondering why they got treatment like that. Okay, so now we go ahead, 2050s. This is where you are. Average annual temperature. Well, you know, averages are made up of long numbers you divide by and get a number, but that doesn't mean that you have really understood how hot it can get or how cold it can get, right? So look at your line there where you are now in the 2050s. Well, we may not be here, but some people might be, we hope. Okay, now let's look at water. And precipitation means any kind of water that falls from the sky, whether it's hail or sleet or snow or rain, and it's average. So average in 1951 to 80, look where you are and look at the color you've got. So Toronto's that little spit here where the little, underneath the finger of Lake Simcoe pointing towards the lake, down to the Lake Ontario, that's where Toronto is, that little blip down at the bottom. That's the dock and portlands and things. So now know where you are, and I'm going to move to the next decade or so. You see what's happening to your area? Again, look where you are. Look what happened. Now look to your right and see where you are in the scale of how much to get in a year's average. Knowing that you're going to have downbursts, droughts, extreme conditions, flooding from time to time. And that's what you're going to be looking at. These are projections tonight in 2050. So, okay. Has anybody found one of these yet? No, I don't think the trilliums are out yet. Okay, so here we go. Here you are. You see this going up till 20, where you are in the brown. And you know, to look to the left, and you'll see you're about 7.5 degrees Celsius. And at the end, you're up to maybe 9 or something like that degrees, average daily temperature. That's just 2014. So you have to extrapolate, draw your line a bit further to get to 2020. Okay, everybody knows what these are, maybe? What are they?
Tulips.
Yes. Now these tulips, I wanted you to see this because these are very close to the original. Do you know where tulips came from in the very first place, where they were wild? No? You know where the Black Sea is, and off the Caribbean, off the Mediterranean, and there's the Caspian Sea east of that. And the mountains of Kazakhstan are the wild tulips. And they were brought down to Turkey by Suleiman, Sultan Suleiman, who was very wise and respected, and he loved them so much he adopted them. People wore them in their turbans. He gave them away as very prized gifts for his people who came to him, all his high VIPs, and it became a symbol for Turkey, but it didn't originate there. And if on tourist Turkey, the logo is still a tulip, and the word tulip comes from the Arabic or whatever language, a turban, because it was in the blossom was in the shape more or less of a turban at that time. And then they got transported over land and over sea to Holland, and Holland became famous as a tulip bulb producer. And they actually had the tulip bulbs as currency. They weighed the tulip bulbs, and that was their currency at the time. And then during the war, they had to eat the tulips of Keukenhof and others to stay alive. But the Keukenhof Tulip Festival was fabulous. You ever get there in the right time. But I wanted to share that little story because most people think they come from Turkey, but they did not. They were cultivated, they're wild in Turkey and cultivated everywhere else. Okay, so now, what you're going to look at is the numbers where you live. So let's say 183 to 217 is you. And that will be what's going to happen with your growing days. So my friend calls it Kentucky. We're going to be Kentucky North. So what are the risks and how, when we talk about destabilization and more extremes more often, this is what you're going to be facing. And a lot of this you already know. The good news is that we might have some more biodiversity as our plants, our native plants dry out when they can't survive or whatever, but the new ones will come in, the new natives will come in from the south and increase our biodiversity. However, when you have to deal with changing climate, warmer winters, this is what we're going to have. The opossums are already here. They were up ages ago in Bruce Peninsula. You probably have opossums where you live. And you may have heard of Lyme disease and things like that. Does anybody know this one? Anyway, no vote.
Grape hyacinths.
Yes.
hyacinth.
Hey, you
Sorry.
guys are good. All right, that's good. Great. They came from my friend Jeannie McWright, who runs Blooming Boulevards. You must get in touch with her if you're thinking of collecting seeds and making your boulevards pretty where you are. She's got a whole great program. So now the big question is the rest. This is for the gardeners to take notes on what you're going to be looking for. This is when you go to the seed store. This is what you should be keeping in mind. I'm going to stand up for a bit. Ugh. Okay. Not disappearing, just standing up. All right. Is everybody okay with that? We can have trees that we transport down from, let's say, the north to try and grow them here, and we get in trouble because they're not used to the false springs that we get here, where you have a warming January, some plot of spell in February, and then our trees here are okay. But those ones that come from the north think it's the real thing, and then their buds get frozen off as it changes back to freezing temperatures to get through the rest of the winter. So this is what you should be doing for choosing species, knowing what you're going to have in terms of weather creeping up on you very slowly, but nevertheless changing. So when you're choosing seeds, you try to get native species that are accustomed to these changes. And they've been toughened up by our weather here, although they may be having to work for lower water or more water or warmer or whatever. They're more or less sturdy standards, right? But you should also be planting some new stuff from the warmer zones. Just experiment and see what works on your soil in your space. And what you're looking for on the back of the package, as you well know, is the hardiness zones, the maps. And this is what's happening now. Look at the X for Toronto, and it was yellow, and now it's orange. And look at how the southernmost temperatures are creeping up. The hardiness zones are coming up, creeping north. So when you look at hardiness zones on the package, remember American zones are not the same as Canadian zones when you're doing hardiness. And that's where Aurora basically is in there. So you can find yourself in Scarborough a little bit to the right of that arrow, I think. But you'll see the orange that creeps over the top end of the east side, sorry, the west side of Lake Ontario. That's where about Scarborough is where you are. Okay. So what are you going to do about the near future? Look to our Southwest Carolinian species. They're already adjusting too. And that Carolinian Canada is a great website. And you'll see some of the wonderful things that you might be able to grow in your garden or in your park. Wouldn't it be fun to have sassafras, for example? I love sassafras. tulip trees are the icon for Carolina and Canada, beautiful tree. But the oaks are spectacular because they're living so long. And there's so many species that are adapted. Swamp oak, swamp maple, all kinds of things are happening in there. And the indigenous people used oak trees incredibly well. By the way, there's a big red oak in Humber Summit, Humber Mead up there, Finch and 400 roughly. And that is a huge tree, a very old, wonderful red oak, historic designation now. Fantastic. You can look that up, the red oak. Yeah. So there it is, that beautiful tulip leaf shape. And you'll see the green salamander, I call it, that's Ontario. And that arm that's reaching out, or the head, whatever there is the edge of that is where you are living at your zone. So this is a huge leaf on this tree. It's a compound leaf, huge long leaf with all these leaflets, beautiful big tree. But look at that range. It's already coming up our way and can grow here. I've cut them down by order because it wasn't native at the time, maybe 10 years ago. And I'm so sorry I obeyed that order, but it was called invasive. Now we would call the new normal. And up here in Aurora, there is a pawpaw tree growing in their arboretum. I've seen it. Yeah. So I might try something like that. Might be kind of fun. So now we go out 30 to 50 years. So we're looking at southern Ohio and northern Kentucky. Sorry. Whoops. So the sassafras tree is one of those wonderful giants. We just discovered some huge giants of several thousand years old now in New Zealand. They've been buried in the mud. It's in the news today. Fascinating history, because you do the annual rings and see what kind of growing conditions those ancient trees had. And now, if you're interested in the diary of your garden, the Plant Watch program allows you to encourages you to record what's blooming and when, to see how the climate is changing. And they're usually tied into understanding what's coming in from the Pacific. Yeah. El Nino and El Nina. So it's been developed about maybe 20 years ago or so out in Lethbridge in the agricultural zone. In Europe, in Germany, there is, I should give you the website someplace, the people are paid to record the bloom times of forsythia in Germany, from the south, in the just south of the mountains there, the south end of Germany, around Munich. Then you go to the middle around Frankfurt, and then you go north to Hamburg. There you can see spring 3 times in that country. And they have people in every village or every agricultural area recording the bloom times of the forsythia. Now, do you imagine why they would be paid to do that and report it into a central database? Can you guess why? It's not just gardeners enjoying forsythia because it's an early bloomer.
Farmers?
Yes, the farmers need to know. And somebody else who wants to make money out of it. Guess who?
Tourism.
Yes. And pharmaceuticals. They want to know when to produce their allergy pills. And make money. So and the little guy or gal in each village or whatever is paid to report. And I can give you the website to look at the latest report from Hamburg. Yeah. So that's kind of fun if you're interested, because some of you do gardening maps of what you're planting every year and things like that, right? Okay, well, that takes us through the main part of the presentation. I have other parts if you're interested or ask questions. I can stop there. I can show you a few more if you want to learn how to measure little trees or see what we did in the schoolyard. But that's the major part of what I had to offer to everybody, unless there was some questions. So that's it. Now, I took a bit longer than I planned, but I wanted to give you all time to read everything. How was the speed of the presentation? Was it okay, or I go too fast, too slow?
It was good.
All right, good.
At the last session, Ruth Alves had a question that wasn't seen. Do you still
Okay.
have it, Ruth? She had her hand up in the question session.
Oh, and I didn't see it. Sorry, I didn't have that
Okay.
part of my screen up, the chat screen. Okay. Is she there?
Okay, I was just wondering if the COVID and the shutdown that we had affected the climate in Ontario. I know they could find
Oh, yeah, well, of course.
the tops of the trees and stuff, but
It'll affect our weather and it'll affect the CO2, but not much. I've been watching that. Thank you for that question. We have less traffic, so we have less fumes from the cars. We
mhm.
have less factories, well, businesses and so on, people not commuting. But it's not a lot. It doesn't really move the needle much in terms of emissions.
Okay.
Yeah.
All right.
People are measuring that because they love to be able to prove that it was really important and it is a help. Every little bit helps.
Yeah.
In fact, today, Maureen, and everyone, I read a newspaper, or at least an article in the news, where the high-end billionaire technology people like Gates and Elon Musk and Bozo, or whatever his name is, I should know, they're doing the high-end stuff, right? But the cheapest way to deal with climate change is to plant trees, because trees absorb the CO2 and pollutants, and they provide shade, they handle our water management. The cheapest way out of this for everybody to get out and plant trees and nurture them with mulch or whatever, So if you really have a chance to want to make a difference, and get everybody mulching trees everywhere to make sure they get through the summer, and plant lots. And your conservation authority would be happy to have volunteers in planting days. But you can plant on your own backyard, you plant on your boulevard, all those places, the parks, the cemeteries, they all need trees.
Where do you find out about those planting days?
Well, it depends on where you live, but in your end, in Scarborough, it'd be the Toronto Region Conservation Authority. It could be in parks like the valleys the watersheds are there's a person in charge at TRCA for different watersheds. There's Highland Creek, there's Rouge Valley, there's Duffins Creek, all of those watersheds right across through Humber and Etobicoke and Mimico going west are all managed. There's about 3 or 4 different watershed managers, and they are planning their planting days. So right now they've already ordered the trees for their planting this spring, and there is a shortage of trees to plant. Now, can you imagine a shortage of trees? Why would there be a shortage of trees? Well, I'll tell you one reason, and that is that Mr. Harris, when he was premier, sold off all the nurseries, the provincial nurseries, and the independent nurseries that wanted to exist sold tree stock that was popular and not as much of it, because those nurseries are huge, and they were left to grow when that was canceled. So those nursery trees are now planted out, and the supply is very tough now to find. My guys who are out there trying to find trees for the Toronto Region Conservation Authority say it's very tight supply. So one thing you could look at is starting a tree seedling nursery. Big time, and farmers, there's different ways of doing it. The city of Mexico City, they had a Spanish civil engineer start growing tree seedlings in raised beds with little water canals running between the raised beds that they could control with a little dam, handmade, everything. On concrete though, but on the little throughways. But they raised seedlings there to plant out as a city. They kept replacing their city trees. They knew they had to keep growing that. So it could be done. It can be done by private people taking it on as a club or a conservation authority and working with them. There's lots of chances one way or the other. Everybody wants to plant trees, especially new Canadians. They love to get their kids out and plant a tree for Canada.
Allison, could I ask something?
Yeah.
Yeah, we've live about the Scarborough Bluffs, and in over 40 years, we have a huge black walnut tree.
Yes.
And last year, for the first time ever, it was very late to get leaves, and it never carried any walnuts. First time in all those years. Now,
Wow.
we don't know what's going to happen this year, but would that be due to climate change?
It could be, but it depends really on two things: your local weather, the precipitation, and the temperature would determine that. But I'm not an expert in what makes walnut trees grow, other than that. So if you have to look at the top branches, the crown, the very top, to
Yes,
see if they're still living well. If they're leafing out or looking sick, then you've got some problem. So the crown dieback, they call that.
I see.
And if it's could be drought, it could be disease, but it starts dying from the top visibly, then you figure out it's one of something, and you could have an arborist or somebody from the town look at it, the town forester.
Yeah.
And also, about black walnuts, they won't let anybody else grow around them. They secrete hormones that
Yes.
go out and so they don't have much competition. But they have the trick is, of course, the walnuts are wonderful for dyes and for food and so on. Yeah. So
But
I don't know
no-
the answer, but I just need you need to look at the crown.
Yes, well, the crown turned out to be okay. At first, we thought it was going to die, but once it had all the leaves, it was beautiful from top to bottom. It was
Yep.
fine. And there are a number of plants that will grow under,
Oh, good.
like white turtlehead, lots of hostas, and
good.
a very tall, a few others. And so we don't bother adding new ones,
No.
just happy with whatever grows. But the
Well,
tree
what-
did turn out good, okay.
Yeah, what I would suggest though, that if you're going to protect it, mulch a big ring around it,
Okay,
up to your ankles, mulch
oh,
roughly, because tree roots grow at the tips,
right,
and the tips are far out from the trunk. They're reaching out for soil. There's a three-way tug of war for every water molecule: the clay or the soil it's in, the
right,
earthworms and other things that live in that back in the little hole in the part between particles, and the little root hairs that are one cell extensions of the living root. That's why you have to be careful when you transplant, that root hair stuff.
yes.
So when you have to think about when a tree falls over, you see the root ball. It's a big flat pancake really often, right? So
Right.
it's a big circle out from the tree that you need to protect. And the kids love to run around a tree and they expose the roots and all that kind of thing right next to the tree, right? So you want to mulch. I would say mulch it, and that way it'll wear down. The mulch will rot in there and give it some nutrients.
It had lots of forsythias are growing below.
Oh, good. Wow. And have you taken some up and pounded the clippings to get them to bloom early?
Well, the one closest to the walnut tree, which is in the lower garden, is the first one to bloom right now.
Protected, right?
Yes,
Yeah, well, I used to take forsythia's branches off, clip them off, and then pound the ends and force them in
Oh.
water. And then I take them to school and teach the forsythia.
oh, you should try that.
Yeah, it's lovely to have early forsythia blooming in your living room.
Thank you very much.
Only some of the branches. You don't need to clip everything, just a few to get your bouquet.
Right.
Yeah,
Okay,
hammer the ends, hammer the branch ends, and then stick them in water.
Okay, thank you.
Yeah. And that's wonderful. Thank you for that info. Yeah.
I have a question.
Yes.
I've read a couple of books about the fact that trees can actually communicate with each other through the root system and their hormones. What's your viewpoint on that?
Oh, I think they do. In fact, it's been proven interesting. The woman who did this work, well, Diana Beresford-Kruger always believed it, because she was, if you read any of her books, fantastic. Barbara Beresford-Kruger, fabulous biochemist, trained by the Druids and all sorts of things. And she's still living in Merrittville near Ottawa. The other person, I can't remember her name, but she did the radioisotope experiments out in BC in the old growth forests. So what she did there was she took little seedlings and put them in plastic bags over them, and she shot a radioactive isotope into the ground to see if it would be taken up and how. And then she tried it so that she would put 2 or 3 seedlings together, but only inject it in one place. She found out that through the root system and the mycorrhiza, the fungus that grows in the soil, these trees are connected. And the old growth forest is a huge network talking to each other all the time under the root system, and they're sharing nutrients, and a stump is sharing itself with other seedlings and things like that. It's an amazing. You should look at that, look it up for that experiment in old growth forest. It is stunning to see the isotopes running around underground. And the other thing is that the herbaceous plants, when they're cut, they do talk to the others plants to tell them that they're being cut or being damaged by an insect or cut or something, by releasing things into the air that tell the other plants they're being hurt. They now know enough. When I first started teaching, nobody ever knew this stuff. This is all later technology, radioisotopes into the ground, technology that allows us to check out aerosols in small molecules, like we're now finding out about viruses. The aerosols stay in the air and move through the air. And so we know now that the plants do that and warn each other the danger is coming. Interestingly enough, one other kind of weird fact, because tree trivia is something I want to promote. When they did these forest fires in BC and had these terrible blazes with the timber there because of the beetle, the things that did not burn were around the aspen groves, which people thought was waste wood because it wasn't cuttable and selling as logs, right? So the aspens were in groves where where the forests are regenerating after a blowdown or something. And the aspens were saved, and they saved the trees around them because they have broad leaves letting out water vapor, cooling the air in that part of the forest. So we're just learning. This was just discovered in this recent pine beetle forest fire stuff by a woman who couldn't figure out why these aspens were still doing well, green and leaves and so on, and groves of them. And it turns out they'd saved themselves and the trees around them. So we have to now look at trees, as I say in ecology class, in the evolution class of evolution. We came from trees. The trees were there before us. We have tree philia. We love green. We feel at peace with green. Green is what gets you out of the hospital sooner if you've got a tree outside your window. Green is why you go to the woods and feel peace, and forest bathing to make your blood pressure go down and more oxygen to your brain and ability to think more. That green, forest green, especially in the summer where you can see the phenols coming off the evergreen forest as a kind of a faint rainbow. That's all the vapors, the organic volatiles coming off and looking at it. We're just beginning to understand these creatures that we are our peers, because a flowering tree is equivalent at the end of the evolutionary ladder as we are. And all the ones that are fossils are the ones that didn't make it. We're the ones who've made it. And those are our peers. We have to look at flowering trees as the very epitome of the plant evolution as we are. So for example, if you look at a moss or a lichen, you're looking at the early evolutionary business of in a forest. A succession in a forest starts with a bare spot, right? And then you have certain things that like to live there. And they live there, and just by living there, they change their place, the conditions, right? You with me? And they then become unsatisfied with what they've got. They can't live there well. So other seeds that have been landing there all the time come in and they do better. So it goes, it's a succession. You can look at a stump in a forest and see the succession of the whole life of the forest on the stump. It's amazing. Lichens, mosses, seedlings, and so on, and then the big trees coming in from the deciduous to the coniferous rather to the deciduous. The fine end of the forest, the one that can reproduce itself, called the climax forest, is stable because its seedlings grow there and can keep the forest going, like the Maple Beach forest does here in Ontario. That's your stable, traditional stable climax community, although we know that can be blown apart and start all over in any place, right? So I'm sort of rambling a bit, but I wanted to share some of these stories because I think it's important for us to understand how trees fit into our world. Hello? You
Oh,
unmute?
yes, that was great. Thank you so much.
You're welcome.
Yeah, that was very informative. Any more questions from anybody?
Alice, I had a quick question.
Yes.
If you had the power to do anything in your community or in the world related to trees, can you explain what it would be and maybe how it would support future generations going forward? If you had the
Wow.
power to do anything.
Okay. I mentioned planting trees. Not just planting, but planting, nurturing, maintaining, and measuring and reporting, recording, because every time we plant a group of trees, whatever species we plant, we have to find out what's doing the best so we can continue to improve the success rate of what we're planting as the climate changes. So we should never plant monoculture because that's death in itself. If you have one disease, and it'll wipe out the whole crop, right? So you have to have a variety. And so you should look at, in your case, I would plant a variety of trees that you think will be working for you and your generations to come. But once you find out every few years, every 2-3 years or whatever, even less or more, you'll be able to change the seeding, grow seeds for those ones that are working, or find somebody who's growing the seeds and plant those trees. It's an evolutionary thing you have to get your head around. It's not going to be the same. The next generation may not see the same vegetation. So how are you going to do that? I think you have to plant everything you can and be wise about what's coming. Do a few of the ones that might grow south a little bit on the other side of the St. Lawrence or Lake Ontario, and then keep going. Grow the seeds, try it, or get the seeds from southern Western Ontario, try them here, and keep looking at the ones from the south of as our new natives. So that's the way you're going to protect your future, by planting lots of trees, figuring out what's working, and keep on going in thousands of trees. We need thousands, millions. The Prime Minister talked about billions. The city of Mississauga talked about millions. Some other people are talking about a few 100,000, whatever it takes. It could be your tree, your 10 trees, your 2 trees. You can do memorial groupings of trees on Legion grounds, for example, for the vets. The Indigenous people can plant ceremonial trees and other trees to remember the women, missing women and children. There's other excuses. The road of heroes, anything that gets you out there regarding gets funding, because they're not, you have to buy the best you can. I know, for example, in my city of Mississauga, they will not plant little seedlings. They'll only plant trees up to your hips, sort of whips, because in the cities, they'll mow them down. The riding mowers are our biggest danger. Not kids, not animals, riding mowers. And whippersnippers, eating away at the bark, riding over them. So that's what you have to protect with.
But it
fence.
also
Here-
damages the bark and the water carrying.
That's right. Yep. Once you go under the bark, the sweet part that animals like to nibble on, the candy, is the layer underneath the bark called the cambium. And that's the one that carries all the food. And then inside is the wood that carries the water. So when a rabbit eats its way around or girdles a tree, it kills the tree. That's one way you can kill it, one you don't like too, you know. Yeah. So you protect the bottom. We always put 2 layers of those spiral tree guards, rodent guards around a tree that we plant, because number one, the rodents will get in there. We make sure it touches the ground more or less so they can't get under it. And then the ultraviolet destroys it over time. So it gets too crunchy or brittle and it breaks. You should also take it off if you're doing it for yourself, take it off in the summer, because the insects like to lay their eggs in the dark spaces underneath the rodent guards. So put them on for winter, for nibbling, preventative nibbling, take them off in the summer so that the insects don't lie there, lay their eggs there. If you're looking
Alice.
at, yeah,
Alice, sorry, your
Yeah.
answer is amazing, but you just had me thinking of something else. When they talk about mass planting for the Highway of Heroes, or in certain areas that you see, there are so many trees within like barely feet of one another. Is that an effective way to use our trees and plant them in the city in this manner?
well, we always try to do at least a couple, like the virus, so many meters apart, 2 meters at least.
Yeah, I see spots where there's barely like a foot apart, like they're
Yeah,
just.
well, that they're
packed.
not gonna, they're competing too closely, I would say.
Yeah,
What you
okay.
could do is what they do in the Philippines, for example, they have 3 layers of trees. You have tall trees. Then you have, that's the coconuts. Then you have the ones underneath, like the coffee trees. Then you have a crop on the ground like the pineapples. So you use your space properly. Don't have them competing. When you grate and put them too close together in a forest, you'll see the overcrowding. They need to meet each other perhaps to provide shade, but they grow a different shape. The crown becomes a cylinder, not a big spreading crown, right, for shade. So you change the shape of the crown when you plant them too close together. Somebody's got their hand up, Gail?
Yeah, I have a question. In our neighborhood, which is Scarborough, I've seen a number of cases where people have removed their trees illegally, and the city didn't seem to have any teeth in it to do something about it.
Yeah.
And also other property owners who are trimming the branches off of their mature pine trees up to like 75% of the branches are missing, and there's just the top. And I think this, to me, is a concerted effort to destroy their trees. So how do we get people to understand the importance and protect city trees on private property?
Yep, I think you have to fight the good fight. Now, one woman mortgaged her house to save the tree on a property line. She got the bylaws changed. So what I'm suggesting is if people are trimming, they call the police and say, we want to make sure our place is safe. So we're going to trim up 1 meter so kids can't hide behind a tree. All right, 1 meter, I can handle that.
That's reasonable.
So that's what you need to get as a bylaw, perhaps.
Well, apparently there is a bylaw, but when we called the city, those who are supposed to protect the tree, they didn't come out on time to deal with anything. And by the time they acted, the tree was
Gone.
irreparably damaged. And it was one of the largest trees in the area.
The other thing that happens is people are building and they're tearing up the roots, not knowing that the roots live so far out of the canopy. So it's and I think you're talking about a bunch of educational meetings where you gather a neighborhood together and do a little, this is what you need to know about your tree, to provide shade, to provide oxygen, to provide fruit or nuts or whatever, just to enjoy ethically and feel better, physiologically feel better. It's measurable. So
people aren't doing that. And I agree with Gail that the city is not acting when they should be. They come too late, or they say, who cares?
Yeah,
You know,
well,
it's
that's
not
the
the
wrong
forestry
attitude.
department's responsible for that, yet they don't act.
Well, then you've got to push them, I think, on that. And they may be in, you have to find out what kind of developers influence they have. Because in Oakville, the developers were getting around it by saying, oh, we'll cut this one, we'll plant little ones over there in the nursery, or we'll do this or do that, right? And they were doing deals. So they have a bylaw enforcement officer or two or a team that went around, not just a forester. So they have to develop more staff to do that, or have a volunteer vigilante group.
Well, I think there needs to also be some provincial will, because if people sort of hike the Seton Trail, there are large housing developments of these massive 4-bedroom, 2-story
Oh, yeah.
homes that are actually, you know, non-functional in the current climate, but
Yeah.
encroaching upon the conservation areas and
Oh, yeah.
the, you know, the sensitive areas.
Yeah. Well, it takes a long time. My friend says almost 10 years to get anything to happen. But I think with COVID, we've got a great opportunity to build back better.
Mhm.
Now is the opportunity to put our platform together, our strategy together, and work together to make this happen. Why should we just have anti-masker protests out there, for God's sake? We should have tree protesters out there. And I know that the people who are given contracts to plan the developments are actually told how far away they should work from the tree. And it's about 1 meter from each side. That's wrong for starters. So some of the planners had to be educated as well about what a tree looks like. Now, here's a quick test that you can do with anybody. Have you got a pencil? I want you to draw a tree, please. Everybody draw a tree. Everybody. Just any tree that you like. And let me look at it, or us look at it, each other's, or whatever you want to do. I want you to look at that tree that you've drawn. Got it? Okay, your favorite tree. Now, I want you to think about what you've drawn. My big question. Did you draw roots?
Let's-
Did you draw roots or not? Most people, if I hadn't given this talk, I don't think anybody would have drawn roots.
No.
And when you walk into a public meeting, you ask them to do that. And nobody will have done it. Unless they're a gardener like you.
And
So that's the first lesson you teach them.
right. And
Where are the roots? The roots are the fingers that grow out of the tree at the top and the bottom. And you know what? Trees grow up and then out, and so do people.
Mhm.
So think about that as another analogy, because we grow stouter as we grow up, at least I did. And we grow taller. With our roots are our tree, and we plant our feet, and they get bigger. We change through size.
Mhm.
So, and make that analogy with trees, because they're holding up that whole weight of the tree is tons of tree, tons.
Mhm.
And you can calculate the tons. I'll tell you how. It's very simple on our website. If you walk out to a tree and at breast height, which is 1.3 meters up, and you circle that tree with a piece of string, that's your circumference. You walk back in and measure it on some kind of tape. You go on our website under tree caching. It'll tell you how to put that in. You know what kind of tree it is. You know its diameter. You can calculate the carbon automatically stored in that tree above ground and all the whole tree. And I can teach you even more. It's very simple. This is not rocket science. You can do this. So this is what the carbon is stored. It's taking it out of the atmosphere and growing wood. And it's growing its roots at the very tips, are very delicate, just like your fingertips, and the tops of the tree where the buds are. And that's what you have to see. And also that around the bark and the circumference of the tree, we know that the layer underneath the bark is where the food flows and the water flows. But the water flows in the wood and the food flows just under the bark. So there's only one ring of cells. This is the magic part about trees. One ring of cells, one single layer of cells has the ability to double itself and split into bark and wood. One cell keeps that tree growing wider diameter every year. So once you nibble that, it's gone. So it's a matter of education. If you took, when you cut down a branch, look at the cut end and see how the bark is very thin layer. Then underneath that is wood, but you've already destroyed that single layer of cells because it's between the two. So there's easy teaching stuff that you could do as a gardening club to teach each other and also your neighbors or your town or group, a neighborhood. I'd be happy to help you with that. It'd be a great thing. And that's one of the reasons I want to mention the biggest tree contest. We're trying to launch people to find the biggest tree in their neighborhood. So maybe I can ask you to be a beta tester for our contest, because I'm going to be asking people to walk around their neighborhood, writing down or making notes on the map where the big trees are and how big they are and what kind they are and how much carbon is stored in them. And then when we'll have, for each species, we'll have prizes. So we'll try and build education as a game through or a contest and give little prizes to people who can find the biggest tree and start to respect their canopy that is spreading under by those trees and the amount of carbon stored in them. Because if we store it in the wood, we can use it for furniture, and floors and ceilings and cupboards, and we store it still. It's only when it burns, it goes back to the atmosphere. So the things, all the wood stores carbon. It is made of carbon. You know, it's pretty spectacular when you think about it. Let me say this, and then I got to shut up because I'm talking too much. But can you imagine a chain? When you remember those chains and you made as kids to put on a Christmas tree with paper hooking between making chains? You remember those? Yeah. All right. Imagine that each one of those is a molecule, a sugar molecule. Okay. So that's how you build sugars, and that's how you build starches, and that's how you build your body. Now, a tree is very spectacular. There's so much fascinating stuff, but a tree makes wood by switching out every other circle to make it upside down. And that makes cellulose, which is wood. So it's not rocket science, a double molecule, one side upside down, and you do that in a chain and you make wood instead of starch. Amazing, isn't it? You see, we're very close. Let me say this as a closing remark. When you look at hemoglobin, and you know that's the red stuff that makes your blood red and carries oxygen. Hemoglobin, you know what molecule is in the middle that you have to eat a lot of to make sure you got enough? Iron, right? Now, if you look at that molecule and you switch out the iron and put in magnesium, you've got chlorophyll, more or less. We're so closely related. Chlorophyll and hemoglobin are just about the same. So there's so many simple things that help us appreciate trees, is what I'm saying. And I'd be delighted to help you with your education program. You guys know better what your community can absorb, because you're the experts now in your neighborhood. You know about trees, you know about flowers, you know about seasons, you know now about weather and climate. You're the ones. This is a generation we can leave as a legacy, passing on this knowledge. These kids and people are urbanites. They didn't come from the farm like my parents did, or I did. They came from a city to live in a city. So now we have to educate them about the trees they don't respect. They're cutting them down because they don't like acorns falling on their car.
Yeah.
It's true. It's true. Instead of collecting the acorns and putting a canvas on their bloody car. Okay.
I have
I'm
one
going to
question.
stop there because we could go on forever, and it's now 8:38.
Well, thank you so much, Alice. Any more questions from anybody, or?
I have one question.
Sure.
Yes.
I have a black locust.
Okay.
It must be 100 years old,
Yes.
and it has damage to the bark on one side of the tree. Is there anything I can do to help it?
How big is the damage? Is it size of your head, your hand, your body?
It's about the length of my forearm.
And how wide is it?
I'd say 6 inches.
Okay. Well, I'm not an expert, but I tell you two things that come to mind from my early days of learning, and I'm not up to date on this, so please take it with a grain of salt, but as a starter information. They used to put pine tar pitch on that to seal it.
Yeah, I know, yeah.
And the other thing they did was they cut strips and made bridges between the two sides, two ends.
Strips of what?
Vertical straps to let connections grow. But I don't know, that may be too old now to do that.
Can
I
I
don't know.
interject? I'll interject, Gail. I would never use pine tar. Trees naturally will heal themselves. They'll put up a layer of callus tissue to
Yes.
protect themselves. Now it depends on how, like your tree is quite large, I think, right? So this is
Yes,
a
it is.
small, it's a small area you're talking about in relation to the diameter of your tree.
Yes.
True? Yeah, the tree
Well,
should
maybe,
produce it.
maybe just, when did this happen? Maybe it's just better just to protect it and let it heal itself like you do a scab.
Yeah.
I don't
Well,
know. but
it's
you
been
could
there
have-
now for, I guess, what, a year, 2?
2 years.
Yeah, about 2 years.
Have you noticed any growth at the edges?
No,
Okay.
although I really haven't had a close look at it just this
But
season.
it might be healing like you do a wound from the edges and it'll, have a look at that and then see.
Thank you.
And you could talk to the city forester. They may have some better ideas, or Ontario Forestry Association, urban foresters. There's wonderful people out there who have, Jack Radecki who knows what to do. Some of these other guys, they know what they're doing. They've been doing it all their lives.
Yeah, it's good. Thank you.
The older they are, the better they are at this stage. You know that because they're not young whippersnappers trying to guess what's good. They know what works.
Yeah.
Yeah. Okay, well, that's good. Wow. Thank you for all these questions. You really got me going.
Well, this was
I'm
great.
thrilled to be able to share my knowledge.
Yes. Any more questions, or shall we give Alice a break now? Is
Well,
that-
I'm thrilled to bits. Thank you so much, Annette, for hosting us because it's hard to manipulate everything, but you're doing a great job.
Well, thank you for very informative. I'm all for trees. We have huge trees. We have 8 70-foot spruce trees
Yeah.
and 2 huge maples and Chinese elm and
Oh
lots
my,
of trees all over the place.
that's great.
And
Well, maybe
I
you
hope-
should host a tree tour.
yes,
Outdoors, we could do a tree tour.
Yes,
Instead of before the gardens start going, we can have a tree tour with bare branches. So we make people identify
Yes.
by bark only or by silhouette only. Yes, trees in winter are a great challenge to identification by bark texture, by silhouette. Yes, we could do that.
we don't even need air condition. We have so many trees.
Oh, you're brilliant.
But like you say, one last thing I'd like to say as far as builders and people, they're mostly afraid of roots getting into their foundations.
Yeah.
Well, they can always cut them off before they get there,
I see, yeah.
but they should never be planted close to the foundation either.
No. Yeah, I've seen
If you
that.
ever go on a very lovely walk down Birkdale Ravine, starting at Ellesmere Road and going south down to as far as Lawrence Avenue, somebody many years ago must have had an amazing tree collection. Take your tree identification book with you. There's every kind of maple tree, every kind of spruce tree, every kind of pine tree, every kind of
Wow,
any tree
wow.
that can grow in this way. There's even a tulip tree right at the north end. And,
Wow.
and it's almost like a collection was made
Yes.
in this area, and it's Birkdale Ravine. And
Birkdale and BIRK.
yeah, Birkdale Ravine. It's between Midland and Kennedy Road.
Brimley.
Yeah, it goes south from Ellesmere Road, just by Birkdale Community Center.
Now,
And
is it,
there's
is
a
it,
trail down there, and it runs down along beside the creek.
what creek is that? Do you know the name of the creek?
Yeah, Highland Creek.
Highland Creek?
I think it's Highland Creek.
Good.
Yes, it is. Yes, it is Highland Creek.
It's
Which
Highland
is-
Creek, yeah.
Highland Creek has more than one origin, you know. But this Birkdale Ravine is along beside the east side of the creek, and there's a paved trail all the way. There's bridges over the creek in a few places. But when I was there with my tree identification book, it almost appeared as if many years ago, somebody purposefully made a collection of every kind of Canadian
Wonderful.
native tree.
Wow.
And you can see the difference between maple trees.
Yes,
There's,
yes.
there's probably 20 different kinds and spruce
Wow.
trees.
Wow.
Yeah, so it's an interesting walk. It's a lovely walk too. On a hot
Ah.
summer day, it's shady. And,
Oh, cool.
And then right down, it ends at just before
Thompson
before it
Park.
gets to the hospital. And yeah,
Yeah,
so
okay.
there's a nice place to go and see trees,
Yeah, wow.
different
that's
kinds,
good. Yes.
and learn to identify
Yeah.
native Canadian trees.
Yes, you know what? If you go to the forest, imagine if you, okay, let me explain something. If you draw a vertical and a horizontal line, and one end is the equator, and one end, from the crotch of the two cross lines, the graph, you draw a vertical line like a right angle to make it an angle right out from the where the two join. So I've got a graph, just 1/4 of a big star. And you'll notice when you start putting tree species, a number of species from 0 up by temperature, from the equator to the Arctic, the tree species decline from the tropics to the Arctic, right? To the tree line. So when we go out here in a normal Maple Beach forest, there's only 8 species that are naturally there. Roughly, about 8. Imagine that, eh? So you don't have to know a lot of different species, but it's kind of fun if you want to enlarge your vocabulary. You can predict before you go anywhere. Now, the same kind of change happens, excitingly, as you go up a mountain. Because you start in the tropics and you go vertically at the tropics up a mountain, the same thing happens with altitude as does with latitude. The number of tree species decreases, and you get to the top, there will be no trees. Okay. Now you talk about climate change, let me add this. If you think about trees leapfrogging over each other by seed being dispersed, what happens to the guy at the top? There's no place to go. And that's what's happening as the climate changes on mountainsides and as we go north. So it's fascinating stuff. As tree populations become used to the new climate, they die off in climate they can't live in, and some of them hopefully move into an area and take root where they can live comfortably. Yeah. But quite fascinating. Well, anyway, 8 species is all you would expect in a normal forest walk in our forest around Ontario, if it's a natural growth. So I'm going to wave good night now. I don't want to tire you all out. You guys have been so patient and so many questions. I love you all. Thank you so very much for a great evening. We really run over time.
Thank you.
Yeah, goodbye all
Thank
the best.
you.
Have a great gardening season. Here's some
Thank
great.
you.
Thank you so much
Thank
for
you.
coming.
Oh, my
you.
pleasure. Okay, take care.
Thanks again.
Bye-bye.
Bye.
Well, bye.
Stay well, stay strong. Yep.